All right. So in this video, we are now going to determine if a certain binomial is a factor of the polynomial that's given. So just don't be nervous if you hear the word binomial, right? This is just a polynomial with only two terms. So something like x plus 5, x minus 3. All right, so that's what I'm saying when I say binomial. So how do we figure out if something is a factor? All right, well, if something is a factor, that means when you divide by it, it gives you a remainder of 0. All right, think about, I know 7 is a factor of 42. And when you do 42 divided by 7, it gives you 6 with a remainder of 0. So that's what makes something a factor. All right, is when you divide by it, it gives a remainder of 0. So if we're trying to determine if something is a factor, the easiest thing to do, so again, what we're going to do is determine if g of x is a factor of f of x, is we need to use the remainder theorem, right? If you're trying to determine is x minus 3 a factor of f of x, just do f of 3. F of 3 would have to be equal to 0 for x minus 3 to be a factor. All right, so let's just run through a couple of example problems. This first one, we have f of x is equal to x cubed minus 4x squared minus 15x plus 18. So I'm trying to determine, is x minus 2 a factor of that? Well, I'm just going to use the remainder theorem, and I'm going to say, well, let's find f of 2. F of 2 is equal to 8 minus 16 minus 30 plus 18. 8 minus 16 is a negative 8. Minus 30 is a negative 38. Plus 18 gives me negative 20. So no, x minus 2 is not a factor. Okay, it's not a factor of g of x. Or of f of x, excuse me. All right, we would need to get out 0. Because if I were to do this division out, I would get a remainder of negative 20. We don't want a remainder. We want a remainder of 0. All right, for this next one, we have f of x is equal to 8x cubed plus 9x squared minus 7x minus 8. And we want to know, is x plus 1 a factor? So I'm going to find what is f of negative 1. Well, that's going to give me a negative 8 plus 9 plus 7 minus 8. All right, I just plugged in negative 1 there. Negative 8 plus 9 is 1, plus 7 is 8, minus 8 is 0. So I can say, yeah, x plus 1 is a factor of f of x. Is a factor of f of x. All right, let's move it along. Let's do one more example. So now I have f of x, and I have, is x minus 2 a factor? So I'm going to plug in 2 to f of x. F of 2 gives me 8 minus 12 minus 8 plus 12. Well, 8 minus 12 is negative 4, minus 8 is negative 12, plus 12 is 0. So yes, it is a factor. And now let's take it to the next step. Let's use this and let's factor f of x completely. All right? Let's actually do this division of f of x divided by g of x. So I'm going to use synthetic division. 1, negative 3, negative 4, 12. I'll bring down the 1 to start. Okay, 1 times 2 is 2, negative 1. Negative 1 times 2 is negative 2, negative 6. Negative 6 times 2 is negative 12. And so it gives a remainder of 0. Good. It should be giving us a remainder of 0. The remainder theorem told us that it would. So now, well, let's see. What exactly did we just do? We basically just showed that f of x divided by g of x would be equal to 1x squared minus 1x minus 6. So that also tells me that I could rewrite f of x as this of course, all in parentheses, times g of x, right? With simple, just I'm going to multiply g of x over to the other side. So now I could rewrite f of x and say, well, f of x is equal to x minus 2 times x squared minus x minus 6. And then, I could actually factor this further. I could factor this to, well, the x minus 2 is going to stay, but I could factor x squared minus x minus 6 to x minus 3, x plus 2. So now I have completely factored f of x, and that is what we are really going to be working on as this unit continues, is how do we factor these higher degree polynomials?